All right, we're looking at 12.2.1, day 2, more trig identities. And yesterday we should have created a toolkit that had a bunch of different trig identities on it for you to reference. So I have this right here. If you want to just take a second and make sure you have all of those from yesterday filled in. We'll be using those a lot the rest of this chapter. And actually, this is about what the rest of the year is going to be about. So all these, proving these trig identities and using this toolkit. So make sure to just double check right now that they're all correct. Okay, so we're going to be referencing that a lot. So question 12-88, it says use your new identities from your toolkit to help you rewrite and solve the following equations in the given domains. So the first question says part A is 2 times cosine of pi over 2 minus x equals 1, and for all x. So this means that we're going to have the plus 2 pi n stuff. It means we can go around the circle several times. So if we look at our toolkit, and I want to see, is there anything that I have on the toolkit that is the same as this question right here. So cosine of pi over 2 minus x, cosine of pi over 2, oh, you can't see that, cosine of pi over 2 minus x right here is equivalent to sine of x. So all we're going to do is just change the cosine of pi over 2 minus x part out and replace it with sine of x, because we proved that yesterday that they are the same thing. So all we'll do is have 2 instead of times all that stuff. Now it's going to be 2 times sine of x, and that equals 1. So this is something that we've solved before. It looks much less complicated. So we can divide each side by 2. So sine of x is worth 1/2. So we're finding out what is the angle that would make the height be worth positive 1/2. So I'm going to draw a little triangle here. So my height is 1/2. And figure out what angle is that going to be there. Well, across from 1/2 is 30 degrees. And that in radians, so please give your answer in radians even though it doesn't specify that, is pi over 6. So that's one location where that works. Another place where the height is positive 1/2 is over in this second quadrant. So that's 1/2. This reference angle is also 30 degrees. So if we were to take straight across is pi and then take away pi over 6 from that, this would be 5 pi over 6. Okay, so those are the two places where it works. In the circle, just going one time around. However, it wants us to say for all x, so all of the answers, if we keep going around the circle. So we'll say pi over 6 plus 2 pi n, which we've practiced saying that before, and then 5 pi over 6 plus 2 pi n. Okay? But the main idea is subbing out this complex stuff for things that we know are equivalent to it. Okay, so that's for A. Second one, part B, says cosine squared of x minus sine squared of x equals radical 3 over 2. And this is just going one time around the circle, so we're not going to do the plus 2 pi n stuff. So if I look at my trig toolkit, here we have cosine squared minus sine squared. That was the question. So cosine squared minus sine squared, this is going to be worth cosine of 2x. So we're going to swap out this stuff in the equation for cosine of 2x on the inside of the parentheses. Okay? So this whole thing right here will just change to say cosine of 2x equals the square root of 3 over 2. All right, now if this was just an x inside here, let's kind of think of it as that way. Just kind of don't worry that this is 2x inside. If this had cosine of x equals radical 3 over 2, I'm going to also draw a triangle here. So I know the horizontal distance has to be radical 3 over 2. Therefore, this side is worth 1/2, and it actually is the same angle as we had in the previous question. This would be pi over 6. However, that's assuming that this was a regular x. So let's set this 2x, because that's what has to be, that's what's inside of here. If I did cosine of pi over 6, you would get radical 3 over 2. Okay, so I'm going to set these two things equal to each other, if that makes sense. Okay, so because it has a 2 in front of it, our answer is really not pi over 6, because there's this 2 here. So I'm going to set 2x equal to pi over 6 and solve it there. So I'm going to get the x by itself, so I'm going to divide by 2, which is the same thing as multiplying by 1/2. So really this is pi over 12 is one of our locations where that works. Okay, we have that. Let's see, another place where our cosine would be positive radical 3 over 2 would also be in this spot right here. Okay, so we have those. And this would be 1 less pi over 6 from all the way around, which is 12 pi over 6, so this would be 11 pi over 6 in that spot right there in this bottom fourth quadrant. However, again, our answer is not just going to be 11 pi over 6. I'm going to set this equal to 2x because that's what should be inside here would be the 11 pi over 6. But that's not our answer since it's just 2x instead of just regular x. So again, I'll set that equal to, let's up here maybe, 2x equals, 11 pi over 6. I'm looking at the wrong part. And then I'm going to also multiply by 1/2 to get rid of the 2. So I just get x is worth 11 pi over 12 is actually another location where that's going to happen. Okay. So let's see. Then we could also, let's see, cosine is positive, so 13. Trying to think about this one here. So we're supposed to get another couple answers here. And I have to figure out why we get those other answers. Pi over 6. Hold on, we'll have to come back to that. Figure out where there's 2 more answers here. Oh, I know why. Because 11 pi over 12, let's just think where that is on the circle. That's not even in these locations, right? That would be over here-ish. Okay. So it's not even like we've gone around a whole time on the circle. We've only gone really, let's see, what was our first answer? Pi over 12 is like super small over here. 11 pi over 12 is really small over here. We need to be in this domain. So since our answers aren't really all the way around the circle yet, they're only really halfway around the circle. We need to think of more places where that could happen. So if we go around the circle again from this first location, that was one of our solutions. So if we add, another time around, or another halfway around from that, we'd get 13 pi over 12 would be another place. And then across from here, from 11 pi over 12, if we go across this way, we need to add pi to it because we've only gone about halfway around. So that's why we're going to add pi to our previous, the first answer that we got. And then the same thing for the second answer. We're going to go pi across. So if I add 12 pi over 12 to this answer, that would give me 23 pi over 12. Okay. We won't be doing a whole bunch when there's like a 2 or some other number inside of the parentheses of the trig function, so don't worry too much about that. But that is why, since we only went basically only around pi for the first 2 answers, so we have to add another pi to each of these original 2 answers. Okay, so that's why that's happening.